The final things that we want to look at in this lecture, in terms of some of the definitions that we will use within thermodynamics analysis, is the definition of cycle. We will talk about cycles, thermodynamic cycles, cycle analysis. So cycles are very important to mechanical engineering thermodynamics, and basically all that a cycle is a process where the process path has identical end states. So you will have two process paths and they both have the same end states. So drawing that in terms of a process diagram, remember we looked at a PV diagram earlier. So here you might have state 1 and state 2, and before we talked about a process path that would be going like that. Now with the cycle, what happens is we'll have another process path that connects the two same end states. And so here you can see it loops around, and that would be in the form of a cycle. So that's a very simple cycle, but it would define a cycle that we will look at throughout thermodynamics. And the last thing that I want to mention is the fact that within thermodynamics, remember we talked about equilibrium and saying that systems needed to be at equilibrium or within equilibrium in order to define the properties. Well, in reality, systems that we study are not in equilibrium, but what we do is we make a bit of an approximation through our modeling, and that is that we study what are referred to as being quasi-equilibrium processes. So let's define those. Quasi-equilibrium processes. And quasi-equilibrium, what it does is it assumes that the system remains close to equilibrium So it assumes that the system remains close to an equilibrium state during the process. Now, this is an idealization, and really no cycle that we're really going to be analyzing will be in quasi-equilibrium. So if that's the case, why should we study them? If they don't really exist, why are we studying them? Well, there are a couple of reasons why we do study them. The first is that it makes our lives quite a bit simpler. They are easy to analyze. So that's the first main reason. The second is that work-producing devices, which is quite often what we'll be studying within thermodynamics, produce the maximum amount of work in the quasi-equilibrium process state. And consequently, when they're considered in quasi-equilibrium, and consequently, any real-world systems would be a little under what we would get out of a quasi-equilibrium analysis. So this is basically the best-case scenario that we're studying. So they basically serve as a standard that we can do analysis on. And we can then compare a real world or actual process to this idealized standard. So that's it for the terminology. We looked at the first law, we looked at properties, we looked at cycles, we looked at states. These are all the things that we're going to be using within this course, and they are very important aspects of thermodynamic analysis. What we'll be doing in the next lecture is we'll be taking a closer look at property definitions and tables, ways to extract the properties, which basically prepares us for being able to do analysis of thermodynamic cycles. So that concludes the lecture. Thank you very much.